Good morning, everybody. I hope your morning classes have been well. I hope you've had a good day so far, and I hope you're ready to continue with a good class period today. I would like to let you guys know that our class period is going to get cut a little bit short today due to our weekly club period, just for you guys to be able to go to your clubs and all the ones that you're involved in and hop around your meetings for those and to figure out what you need to do for those. For those of you all that are not involved in a club, I highly suggest next semester or even next year just to go out and join a club and get involved in some way, maybe even in a leadership position, but I know you guys will have a lot of fun with those, and they'll pique a lot of your interests. But at this time, I would ask that you all put your phones away and get your notes out and get ready for a short lesson today over some of the things that we covered yesterday in our last class period. Now, I know yesterday we did cover our standard equation of a linear function, which is y equals mx plus b. Now our y would equal our y coordinate of our point, which our standard coordinate on a graph would be x comma y. So our y coordinate is equal to our slope. Now I told you guys that we would be calculating slope today, and that is what we will be doing. I know you aren't exactly sure what the slope of a line is and what it means exactly, but like I said, we're going to get into that today. And our x would obviously be our x point in our coordinate, and then our b is our y-intercept. Now, can anybody tell me what the y-intercept exactly means from our discussion yesterday? Yes, sir. Yeah, that's absolutely correct. Our y-intercept is where our graph, our line on our graph, intersects the y-coordinate. Now, in a linear function like we will have, it only connects to our y-axis in one point. And that would be exactly what that means. So, for example, if I gave you a point with the x-coordinate of 2, and we don't know the y-coordinate, and I gave you a slope of 3 and a y-intercept of 0, well, what do you guys think our y-coordinate would be? Well, let's just plug everything into our equation. We have y equals 3 times our x-coordinate of 2 plus 0. Now, obviously this doesn't do anything, so we can disregard the 0. Now 3, can anybody tell me, obviously 3 times 2 is, everybody said it once. Yes, 6. Good job, guys. Can we be a little more enthusiastic? Mr. Smith, would you mind to please put your phone up? I know I asked everybody to. It's just kind of distracting for me, and I know it's probably pretty distracting for you guys. Please do that. Thank you, sir. But again, our y-coordinate using this would equal 6. So, given that we didn't know it at first, we have a y-coordinate. So our new point would be 2, 6. Now, that's pretty good. I think you guys are pretty confident in your abilities to solve for the y. But now we will go over how to solve exactly for the slope. And what is the slope? What does that mean? Now, does anybody have a guess over what that means? Nobody? Okay, well that's good. I can tell you guys, it's pretty easy. Now the slope would be how much our line increases. So for example, which of these two lines has a larger increase? If we started on a flat point, which one, for example, would reach this line quicker? Yeah, obviously it would be this line. So given that, this means that this line has a larger slope than this one. Now, what exactly that means is how much our line rises and then runs. That's what we call it. So our slope is equal to our rise over our run. And you can also, if you're not a fan of the words, you could also just think about it as how much it increases up or down divided by how much it increases either left or right. So for example, if I gave you 2 points of 0, 0 and 1, 1. Now we do have a formula that I would like to introduce. I know most of you guys are not going to know how to do this, so I will introduce this formula. This formula is for the slope, and it is equal to y2 minus y1 divided by x2 minus x1. Again, as you can see, our y's coordinate with our rights, which is up and down because our y-axis is our vertical axis. And our x2 minus x1 refers to our run, which is our side to side, how much the line changes from side to side. So using this point, can anyone, let's call this our first point, and let's call this one our second point. So this would be x1, this would be y1, this would be x2, and this would be y2. So using these, can anybody help me plug in our coordinates into our equation, our new equation? And you guys will need to write this. This equation is extremely important for this unit. But yes, I would, yes sir. Yes, absolutely. So our slope, and again, slope is equal to m. That's what it is in our y equals mx plus b. This is what we are solving for. So our m is equal to our y2, which would be 1, minus our y1, which is 0, divided by our x2, again, the number 1, minus x1, 0. So 1 minus 0 is 1 divided by 1, and obviously our slope would equal 1. Now what this would look like in an equation would be, just for example, if we had a y-intercept of 2, our equation would look like, with a slope of 1, would it look like 1x plus 2? Now this is okay, but we all know that anything times 1 is what? Itself. So we can simplify this to y equals x plus 2. Awesome. So if I gave you a point of an x coordinate of 3, our y coordinate would be 5, given this equation. But if I drew you a graph with each tick representing 1 unit, and I drew the points now, I know that's not the straightest line, but just imagine that being a completely straight line with this crossing at 0. I didn't mean for that to go any down, but that does cross at the point 0, 0. Can anybody tell me what our y-intercept would be? Yes, sir. John, will you tell me what our y-intercept would be? Oh, I told you, I warned you to put your phone up. I asked that you please do that again. Our next warning will result in a lunch detention, but this will be our last example, but I just appreciate if you put your phone up. Again, our b, which would be our y-intercept, would equal 0. Now in this point, for example, this is 1, 1. We don't know what this point is, but this point would be -2, -2. So using the formula that I just gave you, slope equals y2 minus y1 divided by x2 minus x1, what could we plug in? And it doesn't matter which one you assign the first for our x2s and our y1s and everything. You can make this number 1 or this number 1 or this number 2 or this number 2. It doesn't matter. We'll go ahead and we'll just assign this one as our number 1. M equals y2 negative 2 minus 1 over negative 2 minus 1. So in this case, negative 2 minus 1 equals negative 3. And negative 3 over 3, as we know, anything divided by itself equals 1. So our slope in this case is 1. And as you can see, as this point 0, 0, as we talk about our rise, if we're going from 0, 0 to 1, 1, we rise 1 unit, and then we run 1 unit. Now, does everybody understand where our slope exactly comes from in this situation now? Awesome, awesome. Unfortunately, that is all the time we do have today because we do have some clubs, but next time we will start going over what exactly different y-intercepts mean than 0 and how that will affect our slope. Ultimately, it doesn't, but we'll go into why next time. So at this time, you guys feel free to go to your clubs if you are in any. If not, just hang out in here. You can get your phones back out. But good job today. Thank you guys for paying attention. I hope you have a great day. Thank you guys.